What is astrophysics? Astrophysics is the branch of astronomy that uses the principles of physics and chemistry to understand how stars, galaxies, and the universe evolve. It combines observational data with theoretical models to explain celestial phenomena. By studying light, gravity, and other forces, astrophysicists explore the origins, structure, and behavior of cosmic objects, from tiny asteroids to massive black holes. It's a quest to understand the universe's fundamental nature and our place within it. How do stars form? Stars begin their lives in stellar nurseries, vast clouds of gas and dust called nebulae. Gravity pulls these clouds together, causing them to collapse and heat up. When the core reaches a high enough temperature, nuclear fusion starts, converting hydrogen into helium and releasing immense energy. This energy creates a star's light and heat. As the star stabilizes, it enters the main sequence phase, where it will spend most of its life. What powers stars? Stars shine because of nuclear fusion in their cores. Fusion combines lighter elements like hydrogen into heavier elements like helium, releasing enormous amounts of energy. This process balances the gravitational force pulling inward with the radiation pressure pushing outward. Fusion is responsible for a star's light and heat, and is the source of elements that form planets and life. Over time, fusion creates heavier elements, enriching the cosmos. The life cycle of a star. A star's life cycle depends on its mass. Small stars like the Sun spend billions of years on the main sequence, then expand into red giants before shedding their outer layers as planetary nebulae, leaving behind a white dwarf. Massive stars end their lives in dramatic supernova explosions, creating neutron stars or black holes. Each phase of a star's life contributes to the cosmic cycle of matter and energy. What are main sequence stars? Main sequence stars are in a stable phase of their life cycle, where they fuse hydrogen into helium in their cores. This phase is characterized by a balance between gravitational forces and the outward pressure of radiation. Stars like the Sun are main sequence stars, and they spend most of their lives in this stage. The duration of this phase depends on the star's mass. Larger stars have shorter main sequences, while smaller stars can last much longer. What happens when stars run out of hydrogen? When a star exhausts its hydrogen fuel, it expands into a red giant. The core contracts and heats up, causing the outer layers to cool and redden. In this phase, the star fuses helium into heavier elements. For even larger stars, they become supergiants, expanding to enormous sizes. Eventually, these stars shed their outer layers, leaving behind a dense core, which could become a white dwarf, neutron star, or black hole. What triggers a supernova? A supernova occurs when a massive star reaches the end of its life. If it's a Type II supernova, the core collapses, causing a massive explosion. For Type Ia supernovae, a white dwarf in a binary system accumulates matter until a runaway fusion reaction occurs. These explosions release tremendous energy, outshining entire galaxies for a short time and dispersing heavy elements into space, enriching the cosmic environment. What is a neutron star? A neutron star forms from the core of a massive star after a supernova. It's incredibly dense, so dense that its matter is almost entirely neutrons packed into a sphere about 20 kilometers across. Neutron stars have strong magnetic fields and can spin rapidly, emitting beams of radiation that create pulsars when observed from Earth. These stellar remnants are among the densest objects in the universe. What is a black hole? A black hole is an area in space where gravity is so strong that nothing, not even light, can escape. They form from the remnants of massive stars after supernova explosions, or through the merging of smaller black holes. The boundary of a black hole is called the event horizon, beyond which nothing can return. Black holes can grow by accreting matter or merging with other black holes. What lies beyond a black hole's event horizon? The event horizon is the point around a black hole where the escape velocity exceeds the speed of light. Once something crosses this boundary, it can't escape. At the center lies the singularity, where gravitational forces compress matter to an infinitely small point. Here, current physics breaks down, and we don't yet fully understand the laws of nature. What is Hawking radiation? Hawking radiation is theoretical radiation predicted by physicist Stephen Hawking. It arises from quantum effects near the event horizon of black holes. Virtual particles form near the horizon, and one particle falls into the black hole, while the other escapes as radiation. This process causes the black hole to lose mass over time, leading to its gradual evaporation. What are pulsars? Pulsars are rotating neutron stars emitting beams of electromagnetic radiation. As the neutron star spins, these beams sweep across space. If Earth is in the beam's path, we detect regular pulses of radiation. Pulsars are used as cosmic clocks, helping to test theories of gravity and understand the extremes of matter. What are quasars? Quasars are extremely bright and distant active galactic nuclei. They are powered by supermassive black holes at the centers of galaxies, which accrete matter, emitting enormous amounts of energy. Quasars can outshine entire galaxies and are key to understanding the early universe, as they are often seen as they were billions of years ago. How do galaxies form? Galaxies form from the gravitational collapse of gas clouds in the early universe. Over time, these clouds merge and coalesce, creating larger structures. Dark matter plays a crucial role by providing the gravitational framework for galaxy formation. Galaxies then evolve through interactions, mergers, and star formation, leading to the diverse range of galaxy types we see today. What is the Milky Way galaxy? The Milky Way is the galaxy containing our solar system. It's a spiral galaxy, with a central bulge surrounded by a flat disk and spiral arms. Our solar system is located about 27,000 light-years from the galactic center. The Milky Way is a typical example of a spiral galaxy, with billions of stars, gas, dust, and dark matter, all orbiting around a supermassive black hole at its center. What are the different types of galaxies? Galaxies come in three main types: spiral, elliptical, and irregular. Spiral galaxies, like the Milky Way, have a central bulge and spiral arms. Elliptical galaxies are shaped like ellipses and have smooth, featureless distributions of stars. Irregular galaxies lack a distinct shape and often have chaotic structures. Each type tells us something about the galaxy's history and evolution. What is dark matter? Dark matter is an invisible substance that doesn't emit or interact with light, but exerts gravitational effects. It's thought to make up about 27% of the universe. We infer its presence from the way galaxies rotate and how light bends around massive objects. Dark matter helps explain the structure and formation of the universe, but remains elusive to direct detection. What is dark energy? Dark energy is a mysterious force driving the accelerated expansion of the universe. It's thought to make up about 68% of the universe. Unlike dark matter, dark energy doesn't exert gravitational effects, but works against gravity, causing galaxies to move apart faster. Understanding dark energy is crucial for predicting the universe's fate. What is the cosmic microwave background, CMB? The CMB is the afterglow of the Big Bang, filling the universe with faint microwave radiation. It represents the residual heat from the early universe, when it was just 380,000 years old. The CMB provides a snapshot of the universe's infancy and helps us understand its origins, composition, and early development. What is the Big Bang theory? The Big Bang theory describes the universe's origin from an extremely hot and dense state about 13.8 billion years ago. It began with a rapid expansion, cooling down and leading to the formation of atoms, stars, and galaxies. This theory explains the observable expansion of the universe and the distribution of cosmic background radiation. What is cosmic inflation? Cosmic inflation is the theory that the universe underwent a rapid exponential expansion just after the Big Bang. This brief period of inflation stretched the universe, smoothing out any irregularities and setting the stage for the large-scale structure we see today. It helps explain the uniformity of the cosmic microwave background. What are redshift and blueshift? Redshift occurs when a celestial object moves away from us, causing its light to stretch into longer wavelengths, making it appear redder. Blueshift happens when an object moves toward us, compressing its light into shorter wavelengths, making it appear bluer. These shifts help us measure the speed and direction of cosmic objects and the expansion of the universe. How do we know the universe is expanding? The universe's expansion is evidenced by observing the redshift of distant galaxies. Edwin Hubble discovered that galaxies are moving away from us, and their velocity increases with distance. This observation supports the theory that the universe began in a hot, dense state and has been expanding ever since. What are galaxy clusters? Galaxy clusters are large structures consisting of hundreds to thousands of galaxies bound together by gravity. They contain vast amounts of hot gas emitting X-rays and dark matter. Studying these clusters helps us understand the distribution of dark matter and the large-scale structure of the universe. What is the interstellar medium? The interstellar medium is the matter that exists in the space between stars within a galaxy. It consists of gas, primarily hydrogen and helium, and dust particles. This medium plays a crucial role in star formation and the chemical enrichment of the galaxy as it cycles through different phases. What are exoplanets? Exoplanets are planets that orbit stars outside our solar system. Thousands have been discovered using methods like the transit method and radial velocity. Studying exoplanets helps us understand planetary systems and the potential for life beyond Earth. What is a habitable zone? A habitable zone is the region around a star where conditions might allow liquid water to exist on a planet's surface. This zone is often referred to as the Goldilocks zone because it's not too hot or too cold. Finding planets in these zones is crucial for the search for extraterrestrial life. How do we detect exoplanets using the transit method? The transit method involves observing the periodic dimming of a star's light as a planet passes in front of it. This slight decrease in brightness indicates the presence of an exoplanet. By measuring the amount of dimming, scientists can determine the planet's size and orbit. What is the radial velocity method? The radial velocity method detects exoplanets by measuring the Doppler shift in the spectrum of a star's light. As a planet orbits, it causes the star to wobble slightly, leading to periodic changes in the star's velocity. This shift helps determine the presence and characteristics of orbiting planets. What is astrobiology? Astrobiology is the study of the origin, evolution, and possibility of life elsewhere in the universe. It combines elements of biology, chemistry, and astronomy to explore conditions that could support life on other planets. Astrobiologists investigate extreme environments on Earth and analyze data from space missions to search for signs of life beyond our planet. What is SETI? SETI, the search for extraterrestrial intelligence, is an exploration for signals from alien civilizations. Using radio telescopes, scientists listen for patterns or signals that might indicate intelligent life beyond Earth. SETI also involves scanning for laser pulses and other communication methods. The goal is to find evidence of extraterrestrial civilizations and answer one of humanity's biggest questions: are we alone? What are space telescopes? Space telescopes are observatories located in space, away from Earth's atmosphere. By avoiding atmospheric distortion, they provide clearer images of celestial objects. Notable examples include the Hubble Space Telescope, which has provided stunning images and vital data, and the upcoming James Webb Space Telescope, designed to explore the universe in infrared and study the early universe, exoplanets, and more. What has the Hubble Space Telescope achieved? Launched in 1990, the Hubble Space Telescope has revolutionized our view of the universe. It has captured breathtaking images of distant galaxies, nebulae, and exoplanets. Hubble has provided crucial data on the expansion rate of the universe, the life cycle of stars, and the nature of black holes. Its legacy includes thousands of scientific papers and countless discoveries. What will the James Webb Space Telescope do? The James Webb Space Telescope, launching in 2021, is the most advanced space telescope ever built. It will observe the universe in infrared, allowing it to see through dust clouds and study the first galaxies formed after the Big Bang. Webb will investigate the atmospheres of exoplanets and explore the formation of stars and planetary systems, providing insights into the origins of the universe. What is gravitational lensing? Gravitational lensing occurs when a massive object, like a galaxy or black hole, bends the light from objects behind it. This effect acts like a lens, magnifying and distorting the background objects. Gravitational lensing helps astronomers study distant galaxies and dark matter distribution, offering a unique view of the universe's structure. What is neutrino astronomy? Neutrino astronomy studies cosmic neutrinos, nearly massless particles that rarely interact with matter. Neutrinos can pass through entire galaxies without being absorbed or deflected. Detecting these elusive particles helps scientists understand high-energy processes in the universe, like supernovae and black hole collisions, providing insights into otherwise hidden cosmic events. What are gamma-ray bursts? Gamma-ray bursts, GRBs, are intense explosions of gamma rays, the most energetic form of light. They occur in distant galaxies and last from milliseconds to several minutes. GRBs are thought to be caused by massive stellar collapses or the merging of neutron stars. Studying GRBs helps us understand the extreme conditions of the universe and the death of massive stars. What are cosmic rays? Cosmic rays are high-energy particles originating from space, mostly protons and atomic nuclei. They travel at nearly the speed of light and can collide with Earth's atmosphere, producing secondary particles. Cosmic rays provide insights into high-energy astrophysical processes and the composition of distant cosmic sources. How did our solar system form? Our solar system formed about 4.6 billion years ago from a giant molecular cloud. Gravity caused the cloud to collapse, forming a rotating disk. The sun formed at the center, while particles in the disk clumped together to create planets, moons, and other objects. This process, known as accretion, shaped the structure of our solar system. What do we know about exoplanetary atmospheres? Exoplanetary atmospheres are studied to understand the composition and conditions of planets outside our solar system. By analyzing starlight passing through an exoplanet's atmosphere or observing atmospheric emissions, scientists can detect gases like water vapor, carbon dioxide, and methane. This information helps assess the potential habitability of exoplanets. How do supernovae contribute to element formation? Supernovae play a crucial role in creating and dispersing heavy elements. During the explosion, fusion processes forge elements like iron, nickel, and other heavy metals. These elements are then scattered across space, enriching the interstellar medium. This process contributes to the formation of new stars and planets. How do black holes affect galaxies? Supermassive black holes at the centers of galaxies influence their formation and evolution. They can regulate star formation by emitting powerful jets and radiation that heat surrounding gas, preventing it from collapsing into new stars. Black holes and galaxies are intertwined, with each impacting the growth and structure of the other. How do magnetic fields influence astrophysical processes? Magnetic fields play a vital role in various astrophysical phenomena. They affect star formation by controlling the flow of gas in molecular clouds. Magnetic fields also influence the behavior of cosmic rays, the dynamics of plasma in stellar atmospheres, and the structure of galaxies. Understanding these fields helps us grasp the physics of the universe. What is the Fermi paradox? The Fermi paradox highlights the contradiction between the high probability of extraterrestrial life and the lack of evidence or contact. Despite the vast number of stars and potentially habitable planets, we have not detected any signs of intelligent life. This paradox raises questions about the nature of life and the challenges of interstellar communication. What is the anthropic principle? The anthropic principle suggests that the universe's physical constants and laws are fine-tuned to allow for the existence of life. It argues that the universe's conditions are as they are because they enable observers like us to exist. This principle is used to explain why the universe seems uniquely suited for life. What are primordial black holes? Primordial black holes are hypothetical black holes formed shortly after the Big Bang, due to high-density fluctuations. They differ from stellar black holes, which form from collapsing stars. Studying primordial black holes could provide insights into the early universe and dark matter. What is the multiverse theory? The multiverse theory suggests that our universe might be one of many, each with different physical laws and constants. This theory arises from cosmological models and quantum mechanics, proposing that multiple universes could exist parallel to ours. While speculative, it offers intriguing possibilities for understanding the nature of reality. How do we search for dark matter candidates? Searching for dark matter involves looking for particles that could make up dark matter, such as WIMPs, weakly interacting massive particles, or actions. Experiments use underground detectors, particle colliders, and space-based observatories to find these elusive particles. Discovering dark matter would provide crucial insights into the universe's composition. What's the link between astrophysics and time travel? Time travel in astrophysics is explored through the theory of relativity, which allows for the possibility of traveling forward or backward in time under specific conditions. Concepts like wormholes and the warping of spacetime offer theoretical pathways for time travel, though practical applications remain speculative and beyond our current technology. What does the future hold for astrophysics? The future of astrophysics promises exciting discoveries with upcoming missions and technologies. Next-generation telescopes, like the James Webb Space Telescope, will explore deeper into the universe. Advances in gravitational wave astronomy and dark matter research will enhance our understanding of cosmic phenomena. The quest to unravel the mysteries of the universe continues to drive scientific innovation.